Okay, here we go. Oh, it's working. What is a conic section? Does anyone know what a conic section is? Chapter 9:1. There it is. That's a conic. Oh no, that's a comic section, not a conic section. Oops, I made a mistake. I had to throw that in there. Okay, so these are conic sections. Okay, you don't have to draw a picture of this. It's just why they're called conic sections is because if you take a double cone like this and you slice it in a number of ways, you get conic sections. You've seen that's why they're called conic sections. If I slice it this way, if I slice one cone, I get a parabola. Okay? If I slice it horizontally parallel to one of the bases, I get a circle. If I slice it kind of on an angle like that, okay, I get an ellipse. If I slice it vertically, then I get a hyperbola. Okay? Hyperbolas are different than parabolas. Okay? Parabolas only have one part. So see, like if I slice this one, it kind of missed this part of the cone, right? And parabolas go out forever, whereas hyperbolas have two halves to them, and they have asymptotes, whereas parabolas don't have asymptotes. Okay? They're all called conic sections, and this is, you don't have to write this down yet either. We'll talk about this later on in the chapter. Okay? But all conic sections, all of the equations of all these different graphs can be expressed using this form. ax squared bxy plus cy squared plus dx plus cy plus f. Depending on what shape it is, like if it's a circle, I just have an ax squared term, a cy squared, sometimes a dx and an ey, and a constant, but I don't have this one, or I don't have this one. This one, we're not going to really concern ourselves with bxy because that's a rotated hyperbola or ellipse, meaning it's not parallel or perpendicular to the x and y axes. And that's when you get this thing, and we used to teach it where you rotate a parabola so it's not exactly vertical or horizontal, but we're not going to do that in this section. If one of these is missing, like if the cy squared was missing, if I just have x squared, what shape would it be? If I just have x squared, what shape? You're right. If I just have y squared, right, it's also a parabola, right? Right? Except it's a sideways parabola, which we're going to talk about later on. And if I have dx and ey's, then it's a transformed thing. These things kind of move it left or right and stretch it and shrink it and stuff like that. And f is a constant term. Okay? So, we're going to talk about circle first. Okay? And I just copied this from the book. I'm not very innovative. Okay? But if you want to write this down, you can. A circle is a set of all points x, y in a plane that are equidistant from a fixed point, hk, called the center of a circle, and the distance between the center and any point of the circle is the radius. Okay, so the circle, it doesn't include the inside, right? It's just all these points, all the points on the outside. Okay? Hi there. Anna Nickerson. You have to go somewhere at 10:40. There you go. So, do you kind of know that already? You guys know that? Okay. And I think you've seen this before. Well, we're going to do some examples. Yeah, I know when I taught honors geometry, we went through the equation of the circle. Did you guys, most of you took honors geometry? Okay, and this was the equation of a circle. X, did you do it last year in Algebra 2? X minus h squared.
Not really.
What? You did a little bit of it, okay? But the standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared. That's if the center is not at 0, 0, okay? If the center is at 0, 0, then it just looks like x squared plus y squared equals r squared. And that comes out of the that comes, I don't know. No, I'm going back. I just can't get my pen. Okay? That comes out of the Pythagorean theorem if you're interested in knowing where it comes from, which you might want to be at this point. Right? This distance right here, to find the distance from x to h, it's x minus h. You understand that?
Yep.
And the distance from y to k, this way, is y minus k. And this is the radius right here. So if I did Pythagorean theorem, I went this squared plus this squared equals this squared. That's where this particular equation comes from. Understand that? Okay? So, so that's kind of where it all is. Any questions about that? Okay. So it starts off really simple. And then it gets more complicated. Find the standard form of the equation of a circle with the center at -1, 4 and a point on the circle, 5, 7. So you just say x minus something squared plus y minus something squared is equal to r squared. Okay? What's h?
-1.
H is -1, so you make that plus 1. K is 4, so you leave that. This doesn't tell you what R is. How can I find R? Plug in a point, okay? So now I'm going to, so here's a point on the circle, 5, 7. So I'm going to plug that in for X and Y, right? So I plug in that particular point, and now I get 6 squared plus 3 squared equals R squared. So you get, what's that, 36 plus 9? Did I do that right? Equals 45? Did I do, tell me if I make a mistake. Because I've been known to make mistakes before. That's right, 45, right? And so you get, so all you really worry about is R squared. So that goes into the equation, okay? And now I just write this, I rewrite my equation as x plus 1 squared plus y minus 4 squared equals, this is R squared, right? You don't need to square root it, equals 45. And that would be the equation of that circle. Easy enough? Gets harder. A little bit harder, not a lot harder. Should I move on? Moving on. Need to write that down? No, you did already? Okay. All right. So then another example that you might see is, did that one already. Find the x and y intercepts. So this is more like, the equation's really simple, but it's more like applying your knowledge to things. So if I'm going to take a picture of this to put it somewhere else. Okay. So find the x and y intercepts. Who can tell me how to do that? Find the x and y intercepts. Yeah, so the x intercepts, x intercept y equals 0, right? Because that's where it crosses the x-axis. And the y-intercept, that's where x equals 0. So for the first one, you just plug in y is 0, and you solve. Whoops. That's right. So I'm going to go at y is 0, so I'm going to solve this x minus 5 quantity squared equals, I'm going to plug in 0 for y, whoops, not equals, sorry, equal, or plus 0 minus 4 squared equals 52, and I square, don't square both sides yet, okay? Don't square this out. X minus 5 squared, 0 minus 4 squared is, what's that? 16 equals 52. Subtract 16, so you get x minus 5 squared equals 36. Oh, look, nice one. Okay, and then what? Square root both sides. But when you square root both sides, whoops, you have to remember that there's a plus half and a minus half. So you square root this, right? You square root this, but there's a plus and a minus. You know that? There's a plus and a minus when you solve that way. So you get x minus 5 equals plus 4 minus 6. So x equals negative 6 plus 5 or negative 6 plus 5, right? So this one gives you 11, and this one gives you negative 1. Okay? Any questions on that? Yeah. So, so far, if I were graphing this circle, I know that it starts at, its vertex is at 5, 4. So I'm just going to kind of sketch it. 1, 2, 3, 4, 5. 1, 2, 3, 4. So here's the center. I know the radius is the square root of 52. So the radius is about, what's the square root of 52? What number is it close to? It's close to 7, because 7 squared is 49. Okay? So then if I were to draw a circle, right? Watch this. Okay? Whoa. Okay? So the 2 points where it crosses, right, are going to be here at 11, and then over here at your negative 1. Questions? Okay? To find your x, or your y-intercept, what do? Plug in 0 for x. If I plug in 0 for x, so the y-intercept, I get 25 equals, or plus, 25 plus y minus 4 squared equals 52, and y minus 4 squared equals 17. Is that right?
No,
27. Y equals plus y equals 4 plus or minus the square root of 27. Did I go too fast for you guys? Plus or minus, I take the square root of this and then I added 4 to both sides. So one is 4 plus the square root of 27, which would be somewhere up here. Okay? And one would be 4 minus the square root of 27. 4 minus the square root of 27 would be up there, right? This would be 4 plus the square root of 27. Get it? You can rewrite the square root of 27 if you want it as what? 3 root 3, right? But that's basically how you did it. If you get a negative number inside the square root, that means it doesn't have an x or y intercept, right, at those points, which sometimes you will in your own. Can I move on? Okay, moving on. Rolling. Okay. Complete this square. Hey, this is the last problem of this. Okay?
Really?
Oh, I have a U try. Okay? So, when you are completing the square, a lot of times, so this is kind of in that standard form that I showed you at the beginning, but the standard form isn't very useful for graphing the circle, right? So I need to complete the square. Now when I complete the square in a circle or an ellipse or a hyperbola, I need to do it twice, all right? So the key is, first you get your constant term onto the right side, okay? So you get the constant over on that side, so you get x squared minus, and group together your x terms and your y stuff and your x stuff kind of like this, okay, equals negative 6. Now, do you guys know how to complete the square? Do you know? Who knows how to complete the square? Some of you know how to complete the square. I complete the square right here. I take half of this negative 6. What's half of that negative 6? Minus 3 squared. And I take half of this, y minus 1 squared, equals negative 6 plus blank plus blank. What goes in those two blanks? Not negative 3 and negative 1.
3 and 1.
9 and
2 and 1.
9 and 1.
Why?
Okay?
Why?
Why?
So that's the square of
Why?
negative 3, negative 1.
Because. Okay? I thought you guys did. Because if I FOIL this out, okay, on this left side, if I FOIL x minus 3 times x minus 3, I get x squared minus 6x plus 9, which is the same as x squared minus 6x, except I have a 9 there too, right? So in order to keep my equation from being heavy on the left side, I need to bring a 9 over here to make it balanced, right? Okay, you understand? You take half of this and you add the square of that to this side. That will keep your equation balanced, because if I FOIL this out, I get y squared minus 2y plus 1, right? If I FOIL that. And so I essentially, when I rewrote this, right, when I rewrote this as this, I added 9 to my left side of my equation. When I rewrote this as this, I added 1 to the left side of my equation. So to keep my equation balanced, I need to add a 9 and a 1 on this side. Then I rewrite it, x minus 3 squared plus y minus 1 squared equals 3 plus 1, which is net 4. Yay, very good. Okay, so if I were going to sketch this particular circle, I know that the center is at 3, 1, 1, 2, 3, up 1, and it has a radius of what? 2, right? Because this is r squared, so it's got a radius of 2, and so I would just kind of draw it with a radius of 2, which looks kind of like that. There you go. If you had a Mobi board, you could draw circles that good too, that well. Isn't that cool? Okay, so I am going to, I think that's everything. Do you need more time to write that down? Okay. I think